again, we're going to follow the pattern. We're going to test. If everything's well, we're going to do the mean, the standard deviation. We're going to sketch. We're going to do your probability statement, correct it for continuity, do your z-score, find the area. Okay? Our goal is to find the area under the curve. So we're going to start with this little guy, example 4, and it says 58% of adults say that they never wear a helmet when riding a bicycle. You randomly select 200 adults in the U.S. and you ask them whether they do wear a helmet when they're riding a bicycle. They can say yes or no. This is the binomial part. What is the probability? Here's what we're looking for. That at least 120 of those adults from our sample of 200 will say that they never wear a helmet. And the never wear a helmet is exactly what we measured. So we're going to pull out your P, 58%. We're going to pull out your Q, 1 minus P, 0.42. We're going to pull out your N, 200. And now, first thing, we're going to test. N times P greater than or equal to 5. N times Q greater than or equal to 5. So 200 times 0.58 and 200 times 0.42. So which one should we test? We have to test both. Which one is important? The smaller guy. If the smaller guy passes, then the bigger guy passes. So 200 times 0.42, was that greater than or equal to 5? Yep. So this guy, they both pass the test. So we're going to then jump to the mean. This is automatically your mean. So N times P was 116. I think so. Was it 116? Or was that the other column? Yep, 116. Okay, now, ladies, from here, we're going to find your standard deviation. You already did N times P, so now multiply it by Q. Most of the problems, well, probably all the problems that we do, especially their examples, will pass the test. Otherwise, we'll have no work to do with them. So usually they'll leave you those, the separate ones, just asking you if it passes. But once they start working on these, of course they're going to have to pass. So we figure out your standard deviation, and we get to your standard deviation, 6.98. Okay? Now, we're going to make your sketch. We're going to say the mean is in the middle, and the standard deviation is 6.98. For the sketch, can I use 7? Sure, why not? It's a sketch. I still get a placement. I'll be able to figure this out. Okay, it's going to be greater than 120, so it's going to be up there somewhere. So I'm just going to add 7 and subtract 7, and I'll be fine with that. Okay, so now I get to my probability statement. My probability says at least 120 adults will say they never wore a helmet. How do I say that in a probability statement? What's at least? Greater than or equal to. That's the least it could be. Think money in your pocket. You have at least $120. You have 120 or more. So, the first number is 120, 121. This is my low end. I drop it 0.5. There is my corrected probability statement. I look to find 119.5 somewhere over here, and I want the area to the right. Is my area going to be less than 50% or more than 50%? Less than 50%, because it's less than half of my curve. So I apply my z-score formula to it. X, 119.5 minus the mean gives me a positive z-score. Divide by 6.98, and I come out with a z-score of 0.5. I look up 0.5 in my table, and I find 6.6915, and I say my area is supposed to be less than 50%. So what do I do? Subtract it from 1. So my final answer is 0.3085. Almost 31% of the 120. I will expect about 120. Well, let me say it again. About a 31% chance that I will get at least 120 adults to say that they never wore a helmet when they rode a bicycle.
What does that say? Near the 25.
Z equal. God bless us. That's your Z-score. And it makes sense. Doesn't that fall between the 0 and the 1 somewhere? Right? Okay. The sketch tells us I'm less than 50%. It's okay on your sketch to round. Like 6.98 really is the closest to 7. So rather than have to keep adding that, if you round to 7, you're close enough. You need this for a reference. We're not taking our exact values off of that because we can't find the area anyway. Yeah.
With the NP and the NQ, which one are you supposed to try first? The one that's bigger or the one that's smaller?
Well, you try the one that's smaller because they have to be greater than or equal to 5. Like if I say 20 times 0.8, or I say 20 times 0.2, 20 times, well, let's make it 30. 30 times 0.8, I'm still not going to make it. Let's do 60. Let's do 100 times 0.05, so 0.04, and 100 times 0.96. Let's make the words obvious. So if I multiply 100 times 0.96, I get 96. If I multiply 100 times 0.04, which is the 1 minus, I get 4. So if my lower one is not going to pass, I don't even care about my higher one because my lower one failed. Most of the time, the reason everybody does this one first is because that's your mean. You're going to have to do it anyway. So it doesn't really matter if you didn't, if you just tested the other one first. And you can almost see with those kind of large numbers, it's going to work. And your book, of course, is not going to write a whole problem out and then make it not work. Because the idea is to go through the examples. So that's why they always tend to be working when we do these examples. Okay? Everybody good with this? Correction for continuity? Everybody okay with the correction?
How do you know it's the Jason or the symbol or equal to?
At least.
No, but like the equal to.
Over here? It doesn't matter if you put an equal to.
Oh.
It doesn't really matter. The book, the old book would keep, I know sometimes kept the original sign. The new edition doesn't, because it doesn't really matter. You'll never hit 119. But if you prefer to keep the sign the same as your original statement, that's fine too. It doesn't really matter because you won't hit that greater than or equal to thing. It will never hit 119. Ladies?
No, we're talking about that.
Question?
No.
So are we good? Everybody with me? We're testing, finding your standard deviation and your mean, sketching, z-score, area. Now, the thing about this is, if you forget to do your mean and your standard deviation, as soon as you go to your z-score formula, you're going to say, what's my mean? What's my standard deviation? So that's going to force you to remember to do this. Because sometimes we kind of forget this, we test, and then we move on, and you would be stuck. You'd be stuck and say, oh, where did I get my mean from? All right, we're going to do one more, and that's example 5, because it has an equal sign. That's right on my desk, honey.
Okay.
You finished already?
Yeah.
Good. Thanks, Camille. Okay. Example 5 says, a study
You
of...
know what's that?
Glad I got it here.
Huh?
She was mad.
Why was she mad?
I'm just kidding.
The door probably just shut. Weird. Camille's a sweetheart. Okay. One problem, guys. One more problem. A study of NFL retirees aged 50 and older said that 62.4% have arthritis. We randomly select 75 NFL retirees who are at least 50 years and older, and ask them whether they have arthritis. What is the probability that exactly 48 will say yes? How do I write that statement?
P equals
Equals
0.6. Oh, wait, sorry. X
equals
48. Good. Now, remember, you're expanding these to find the area under this curve because you have discrete values. So our curve is continuous. So what happens when you have an equal? So say here's your curve, and here's 47, and here's 48, and here's 49. 48 is a point. There's no area under that curve, really. So I have to expand this guy to give me a bar so that I can find the area under the curve. Remember the other diagrams we looked at of all the curves? They had all the bars in there. They showed you the bars, right? So you could see the bars. That's the bar we need to expand. So let's pull out our information. How do I write 62.4% as a decimal?
P equals 0.6.
Good. And what's my Q?
Q is 0.376.
Okay, it's still the 1 minus P. And my N is 75. Should we test? So technically, we need to make sure we pass. We're going to definitely check the smaller one. We pass and we pass. So the mean is the same as our N times P. So N times P comes out to be 46.8. Okay. Find your standard deviation. Kind of flows a little bit. You already have your N times P. Multiply it by your Q. And you'll find your standard deviation. The 4.19. We'll use 4.19. That's fine. Okay. Make your sketch. Your mean is 46.8. Now, I want to go to wherever 48 is going to be located, to the right a little bit. So I'm just going to go one more over and add 4.19. So I'm going to get 50.99. So it's somewhere over there. Let's expand this probability statement for correct or for continuity. So how would I correct this statement? I need to create a bar off of this. I need to go 0.5 that way and 0.5 to the right. 47.5 to 48.5. I've expanded into a bar. So now, instead of getting one little point here, I'm going to get a bar like this. And that's the area I'm going to find. The area associated with that bracket there, from 47.5 to 48.5. This still works the same as your in between. Now, another good thing is, by looking at it on this graph, this area is far greater than if my bar was over here, wouldn't it be? My bar over here would be like next to nothing. My bar over here is a good little piece of my curve. So for the in-between, you do 2 z-scores. Do it again. This one, again, works the best in your calculator. If for anything else, if you don't get the calculator, the in-between one is the nicest for your normal CDF. Because that's your lower limit, that's your upper limit, you know your mean, you know your standard deviation. It avoids this part right here with your z-scores, it avoids finding your z's, it avoids finding your areas and subtracting the areas. So find your z-scores associated with this. And we can see that they fall between the 0 and the 1. Find your areas associated with this. And subtract your areas. And you find your probability. Now, don't forget, finding an exactly is also tougher. If the probability is small that you'll find an exactly one thing. Out of all the 75, what's the chances that I'm going to get exactly that 48% said yes? If I said from 45 to 49, that's a lot better for me, a range, but picking one exact value, that's a tough one. Same as if I surveyed everybody here and said, what's the probability that exactly 4 of you would say you're going to the movies tonight? Well, rather than say, what's the probability that maybe less than 10 of you are going, or from 5 to 6, 5 to 8 of you are going even. You know, it's a harder thing to pick one number. Are we okay with that? And it's these problems. Now, this, guys, if you listen 1 minute, this one is just making you do the test. And then if it passes, finding the mean and the standard deviation. There is no probability statement with it. The directions for that one are just to say, test this. Tell me if I could use the binomial, I could use the normal curve to approximate a binomial distribution.
Wait, did we already do 1 through 14?
You already did 1 through 14.
Watch this.
Yeah. Yeah. So, therefore, all I want you guys